Hello guys, welcome to Sunya IAS. So today we are here at yet another discussion session of previous year questions CSAT, right? And the topic which we are going to cover today in this series is going to be permutation and combination and probability. This is quite an important topic and therefore we'll be covering this particular chapter in two videos in two parts. So this is the part 1 video and here we'll be covering the idea of permutation. Okay, in the next video which will come after this, we'll be talking about combination as well as the idea of probability. Okay, so in CSAT most of the questions are being asked from permutation. So let us talk about it first. But before that, let us have a look at our online and offline hybrid course for CSAT, in which we are covering all the topics which are required for crossing the 33% barrier. And after that, we'll talk about the idea of permutation. So what permutation actually is? Permutation simply means arrangement. Okay? Different types of arrangements which are possible are called various permutations. Suppose, for example, let's say we have the 5-letter word Sunya, which is nothing but the name of our institution. And if someone says in what different ways you can arrange these alphabets of the word Sunya to create different words without any repetition of these alphabets. So suppose we want to create various 5-lettered words. If we talk about the positions, so this is going to be the first position, second, third, fourth and fifth. Okay, these are the various positions in which we can place the alphabets to create a 5-letter word. Now, if we want to fill the first position, we have overall 5 letters to choose from. Okay, so the first position can be filled by actually 5 letters. After that, the second position, suppose we have chosen A for the first place here. How many choices are left for the second place? So now we have 1, 2, 3 and 4 letters to choose from. So here we have overall 4 choices. Let's say we choose N at this place, right? So then for the third place, we have only 1, 2 and 3 letters to choose from. So we have overall 3 choices. And let's say we choose S at this position. So we have S at this position. Now when we talk about the fourth position, we have only 2 letters Y and U to choose from. Sorry, 2 letters. So here we have 2 choices at the fourth position. Let us say we choose Y at the fourth position. So what about the fifth position? Here we have only 1 choice, that is U. So here we will have only 1 choice and that will become U simply. So what are the different number of ways in which you can rearrange the letters of the word Sunya to create different 5-letter words? So here is one such example. We can create overall many such examples. So what will be the total such numbers? They will be simply multiplication of 5 into 4 into 3 into 2 into 1, which comes out to be 120. So there are total 120 ways in which the letters can be rearranged to create 120 different words, and this example is one of them and Sunya is also one of them. Okay, so this was the basic idea of permutation, and based on this idea of choice, how many choices do we have, we can solve various questions of this topic. Okay, so here we have the question. In a question paper, there are 5 questions to be attempted and answer to each question has 2 choices, that is true or false. So there are overall 5 questions and you have the choice of true or false in each of them. So let us write it down. We have question 1, question 2, 3, 4 and 5, right? And for each of the questions we have only 2 choices. The choices are true or false, right? So for the first question, second, third, fourth and fifth, for all the questions we will have only 2 choices. Then the question further says that it is given that no 2 candidates has given the answers in an identical sequence. So it is saying that whatever be the candidates are, they are all giving different answers, all of them, no one is giving same sequence of answers. So what is the maximum number of candidates which are possible? So it is saying if each candidate is giving different sequence of answer, what is the maximum number of candidates? Let us put it this way, how many different sequences are possible for this particular question paper? So simply we will use the idea of combination. So here you can see at the first position we have how many choices? We have either true or false, that is 2 choices. Similarly here we have 2 choices. For the question 3 we have 2 choices, 2 choices and 2 choices. Overall, in order to fill the question paper, you will be having 2 into 2 into 2 5 times, that is nothing but 32 ways. These are the 32 ways in which you can fill up the question paper. 32 sequences are possible, and if you want, each student or each candidate is making a different sequence. So maximum number of candidates which are possible are 32. So we have option number D, which is 32 candidates as the total number of students. Okay. Moving on to the second question. It says one non-zero digit, one vowel and one consonant from English alphabet are to be used in forming various passwords such that each password has to start with a vowel, okay, and it has to end with a consonant. So what will be in between? Obviously there are vowels and consonants. Also there are a non-zero digit. So this place will be occupied by a non-zero digit. Okay, so the password will be of 3 characters. Further it says how many such passwords can be generated. So overall how many passwords can be created in this way. So let us talk about some basics. I hope in the English language you must know that there are overall 5 vowels which are A, E, I, O and U. Okay, these are the 5 vowels. So here we will have 5 choices. Then when we talk about the consonants, all the alphabets other than the vowels are called consonants, B, C, D and so on. So if we are having overall 26 alphabets, out of them 5 are vowels. So how many will be consonants? They will be simply 21 in number. So we are having 21 consonants actually. So we have 21 consonants to choose from. Finally we are having a non-zero digit. These digits are from 1 to 9. We are not including 0. So overall we are having 9 choices here, 1, 2, 3, 4, 5, 6 or 7, 8, 9. So out of these 9 digits we can choose any one. So these are going to be the total ways in which we can create passwords, and when you multiply these values you get 945. So 945 such passwords can be generated. So option number C is going to be the correct option in this particular case. Okay, so we are using the same idea of how many choices do we have. Moving on, for question number 3 we have how many different 5-letter words with or without meaning can be constructed using all the letters of the word Delhi, so that each word has to start with D and end with I. So we have the word Delhi. Okay, so what are the letters? We have D, E, L, H and I, and we want to create different 5 letters word from it. So these are the different 5-letter words which are possible. Now he is saying each word has to be starting with D. So we lock the first position with D and they have to end with I. So we have to lock the end position with I. How many digits are left in between? We have 1, 2 and 3. 3 letters are left in between. Okay. So we have chosen D already and we have chosen I already. We have only 3 more digits to choose from, 4 letters to choose from, which are simply E, L and H. So at this first position we can choose any one from the 3. So we have 3 choices overall. Suppose we choose one of them. So after we choose one of them we have only 2 choices left here. And when we choose one more we have only 1 left which we can fill at this place. So overall if D and I are fixed at the beginning and at the end, we will be having overall 3 into 2 into 1, that is 6 ways in which we can create different letters. So correct option is going to be 6. So we can create 6 different alphabets, 6 different words from the alphabets. So same idea. Now this is one more question. It says that for a sports meet, a winner stand has to be created, and the winner stand should have 3 wooden blocks as it is shown here. So you know this is a winner stand. This is the position for the first player, for the second one, and for the third one. This is the way you might have seen it in television or in cartoons or somewhere else. This is the winner stand, and you want to fill it with different colors. So overall you have 6 different colors which are available to you, and you want to paint each of the 3 blocks with a different color. So how many ways? Okay, in how many different ways the winner stand can be painted if no 2 of the blocks have the same color? So you want to paint each block. You have 3 blocks overall. You want to paint each block with a different color without any repetition. So suppose you have overall 6 colors, right? So the first block can be filled or painted with any of the 6 colors. So for the first position we have 6 types of different paints which we can use. Suppose we use the yellow paint at this place. So let us paint this particular block as yellowish, just so that we can visualize. So if we paint this first block as yellow, we cannot paint any other block as yellow, which simply means in order to paint the second wooden block, we have only 5 choices instead of 6. So this block can be filled with overall 5 colors. We can choose any one from the 5 colors. Now let's say we are painting this particular block also with bluish color. So here we have blue color for the second block. So now when you have used yellow also and blue also, you cannot paint the third block with these 2 colors, and now you have, instead of 6, only 4 choices left to paint the third block. And so the third block can be painted in 4 ways. Let us say we are using green color to paint the third block. So this is the third block now. So this is one way of painting all the blocks. We can have different such ways. So what are the total number of ways? Total number of ways will be 6 into 5 into 4, and that product comes out to be 160. So the overall blocks can be painted in 120 ways. So option number A is going to be the correct option in this particular case. Okay, so same idea based on how many choices do we have. 5th question says, how many 3-digit natural numbers without repetition of digits are there such that each digit is odd and the number is divisible by 5? Okay, so the question says that how many 3-digit natural numbers are there. So we want to create 3-digit numbers such that each digit is odd. So if each digit is odd, what are the possible choices do we have? We have 1, 3, 5, 7 and 9. We have to choose from any one of these digits. And then the number should also be divisible by 5. That means the last digit of the number should definitely be equal to 5. There is no other choice. So the last position is automatically filled by 5. We have the remaining 2 positions, and for the remaining 2 positions we have overall 4 choices. So let's say we have to fill this 100th place. This 100th place we have to fill. For this we have 1, 2, 3 and 4. We are having overall 4 choices. Suppose if we fill this place with one of the letter, with one of the alphabet, with one of the number here, sorry for that fumbling, not letter but the number. And in this position we will be having, after 1 is chosen, we will be having 3 more choices to choose from. So here we can have 3. Okay, so we here have 3 numbers to choose from. So overall we can have 4 into 3, that is 12 such numbers which have each digit as odd and the number being divisible by 5. So the correct option is option number B. So here you can see this question is actually a mixed question. It is using some concepts of number system also, which we saw previously. All right, moving on, we have this question. What are the number of numbers from the form 0 decimal xy? So we have the form of number as 0 decimal xy. So we have a decimal number in which there is some first position and there is some second position after decimal, where x and y are, read the word carefully, distinct non-zero digits. So first of all, it is saying that x and y are non-zero digits, which mean x and y are having the value from 1 to 9. Also they are distinct, which means x and y are different. X and y are not equal to each other. So what is the way? So we can have overall from 1 to 9, we have overall 9 choices to choose from. We have overall 9 digits to choose from at the place of x. Now if we have chosen one of the values here, y will have, since y is not equal to x, we will have only 8 choices, 8 digits to choose from. So therefore this position will be filled by 8 choices. So overall this number can be written in 9 into 8, that is 72 ways. So overall 72 such numbers are possible in the form of 0.xy, where both x and y are non-zero digits and they are distinct, that is not equal to each other. So overall 72 ways is the answer. Moving on to the next question now. We have this question, question number 7. And in this, there is a level up. So we'll be using a concept just a step more. So let us see. So we have using digits 2, 2, 3, 3 and 3. How many distinct numbers greater than 30,000 can be formed? How many different numbers which are greater than 30,000 which we can form? So suppose we have to create 5-digit numbers which are greater than 30,000. So if a number has to be greater than 30,000, then definitely the first position has to be filled by a 3 without any doubt. So this first position is actually logged for 3. What about the next 4 digits? So here we have overall 4 choices for this place. Then we have 3 choices for this place, 2 and 1. So we have 4 into 3 into 2 into 1. Overall 24 ways to write this particular letter, right? This is the simple approach we go with. This is the overall choices. So overall we are having 24 such numbers, but the story is not that simple. So we saw the example of Sunya. We saw the example of Delhi also. When we have Delhi, if we want to create different 5-digit or 5-lettered numbers, sorry, not 5-letter numbers, but 5-lettered alphabets, we'll be having here at the first place we'll be having 5 choices. Here we will be having 4 choices, 3, 2 and 1. This will be the way in which we will be filling, right? Because all the digits are different. Now let us, instead of Delhi, take the example of Mumbai. So here we have the word Mumbai. Here you can see, here M and M are repeated 2 times. So what are the different ways which are possible? So different ways which are possible if you want to create 6-lettered numbers, sorry, 6-lettered words, then you will be having, at the first place you will be having 6 choices, then 5, then 4, then 3, then 2, then 1. But one thing is there. Since this M and this M is identical, if they change their places, we do not get any new number. So if one says that I am replacing this M with this M, again I will be getting nothing but Mumbai. And in this old approach, we are counting the 2 words as the same. So there is double counting going on. So let's say we are having 2 different words. Someone says we are making MMUBAI and another word is MMUBAI. You will argue they are both the same words, but one can say no, this is the first M here, this is the second M here. No. Someone can argue, okay, this is the another word. I'm using this M at the first position and then this M at the second position. But how does that matter? Both of them are the same. So these two words are the same. And in order to have avoiding this double counting, we just divide this overall value by 2. That is the idea which we are going to follow in the previous question. So here we have all the numbers like this. But since we want to avoid the double counting, we have 2 2's here and 2 3's here. We are going to divide our answer by 2 and also 2. Because we have 2 2's and 2 3's. So that is why we just divide it by 2 into 2, that is 4. And overall we will be having 6 such numbers. Okay, so the correct option for this particular question is going to be 6. Okay, so these are the things which we are covering exhaustively actually in our course. So such questions cannot be solved by simple choice. The level up keeps on increasing, and you have to update yourself. The basics just cannot work anymore. You have to just understand the tougher concepts of P and C. So now we have the 8th question. Now it says, if 2 boys and 2 girls are to be arranged in a row such that girls are not next to each other, then how many possible arrangements are there? So what we are having in this question is that we are having 2 boys, let's call them B1 and B2, and we are having 2 girls, let's call them G1 and G2. Okay. In how many total arrangements they can be arranged? So they can be arranged in 1, 2, 3 and 4. In the first place we can have 4 choices, then 3 choice, then 2 and then 1. Overall we can have 44 ways of arranging the boys and girls. But it says that we should arrange them in such a way that the girls are not next to each other. We have to find those ways in which the girls are far apart, not next to each other. So how can we do that? So instead of finding those ways in which the girls are not next to each other, we can do the reverse process. We can find the ways in which the girls are close to one another and then subtract them from the overall ways, total ways which are possible. So this is nothing but the total ways, right? What are the ways in which G1 and G2 are always together? So for this we have a set methodology. We just assume G1 and G2 to be a single person. So instead of 4 people, we will now have 3 people, which is B1, B2, and we will have G1, G2, both the girls at a same place. So overall we have to place them in 3 positions. Here we have, first we have 3 choices, then 2 choices and then 1 choice. So overall we have 6 such ways, as you can see. But one thing is also there, the order of G1, G2 can also be reversed. So you can have, instead of G1, G2, you can have the order G2, G1. So same cases will also be applicable for G2, G1 also. So just simply multiply it by 2 just to account for the different order of G1 and G2. These are the overall ways in which these girls will always be together, and that ways are simply 2 into 2 into 3, which is nothing but 12 ways. So if we know the total number of arrangements, which are 24, and we know the arrangements in which both the girls are together, we can find the arrangements in which the girls are not together. So G1, G2 not together will be simply 24, the total ways, minus the ways in which they are always together, which is going to be 12 ways. So there are 12 ways in which G1 and G2, both the girls, will not be together. So we have option number C as the correct option in this particular case. Okay. Moving on now to the next question. We have this question number 9. It says the letters A, B, C, D and E are arranged in such a way that there are exactly 2 letters between A and E. And how many such arrangements are possible? It is saying now that we are arranging the 5 letters in such a way that there are always exactly 2 letters between A and E. Okay, so in this question, you have to think about different cases which are possible. This is not a straightforward question. You have to think of different ways which are there. So suppose you want to create different 5-letter words and you want to have gap of exactly 2 between A and E. So one such way is you place A here, gap of 2, and you place E here, right? Reverse case is also possible. you can have the case in which everything is same, just that E is at the first position and A is at the fourth position. Is there any other way in which these A and E can be placed? Yes, of course there are. So we have one more way in which we can place actually A at this position and E at this position, right? So we'll have having two letters exactly in between. Similarly, we can have one more arrangement, and in which E and A will be reversed in position. So here we'll have E and here we will have A. So these are all the possible 4 cases in which A and E will have exactly 2 letters in between them. Okay? You can try and check. There are no further cases possible. So we have overall case 1, case 2, case 3 and case 4. Okay? So how do we fill the remaining places? To fill the remaining places, we have 3 choices, which are B, C and D. This position can be filled by 3, this by 2 and this by 1. So we have overall 3 into 2 into 1, that is 6 ways. Okay, 6 ways in which A and E are at this position. Similarly, here also we have 3 into 2 into 1, that is overall 6 ways for here also. Here also we can have 3 choices here, then 2 here and then 1 here. Similarly, we have 6 ways of having such words where E and A are occupying the second and the fifth position. Similarly, we will have here 3 into 2 into 1, that is again 6 ways. So overall in 4 different cases, we have 6, 6, 6 and 6 cases. So we just add all of them up. And in this way, we will have total ways will be, let me write it here in the downwards direction. We have total ways as simply 6 plus 6 plus 6 plus 6, that is 6 into 4, that is 24 ways. So overall, there are 24 such arrangements in which you can arrange A and E to create different 5-letter words, such that A and E will have exactly 2 alphabets or 2 letters in between. Okay, so this is again a level up from the previous questions we saw. So until question 6 or maybe 7, I guess, the questions were quite straightforward. Just the choices were there. But now we have to think of various cases which can be there. So this is one such question. Moving on now to question number 10. It says, there are 5 tasks and 5 persons. So suppose there are overall 5 tasks. Let us place them like this. So this is task 1, task 2, task 3, task 4 and task 5. Now the question says that task 1 cannot be assigned to either person 1 or person 2. So this task 1, neither to person 1 and neither to person 2 it can be allotted. Task 2 must be assigned either to person 3 or to person 4. This is the criteria for task 2. You must have either person 3 or person 4. Okay. And now one more criteria is every person has to be assigned only one task. So in how many ways we can assign the different tasks to different people is being asked. So this is the criteria that first task we cannot have 1 and 2. And for the second task, we should have only 3 and 4. So in this question also, we will have to think of various cases. And there will be 2 cases possible. Since the second task has to be assigned to either person 3 or person 4, we will have 2 cases. We will have the first case and we have the second case. In the first case, we assign the second task to 3 and lock it here. Similarly, in the second case, we assign the second task to 4 and lock it at this position. So this, in case 2, the task is assigned to person 4, right? Now the question further says that how many persons we have overall? We have 5 persons, which are 1, 2, 3, 4 and 5. Now if task 1 cannot be allotted to 1 and 2, then only if 3 at this position, we have 4 and 5 to be assigned to task 1. Since the task 1 cannot be given to 1 and 2, right? And we have already assigned 3 at the task 2, then how many people we are having to choose from for task 1? They are only 4 and 5, right? So here we have only 2 choices to choose from, either 4 or 5. So 1 is fixed, 1 more you have chosen. Now you have 3 persons to choose from for other tasks. So we have 3 into 2 into 1. Similarly, if we look at this way, if we are having, let me write the blocks again here. Similarly, again, if we are having 4 for the second task, and for the first task, we cannot choose 1 and 2. So how many choices are available? Since 4th is assigned the second task, 1 and 2 are not eligible for this. We have the choice of only 3 and 5. So this place can be filled by only 3 and 5. Overall for this place, we have 2 choices, right, out of 3 or 5. This place we have already logged by 4. Now we have 3 more choices and we have 3 people to choose from. So this position can be filled by 3, then 2 and then 1. So overall, according to case 1, total number of cases will be, let me just write the multiplication on the sidelines. So here we'll be having 2 into 3 into 2 into 1. That is 12 ways. And here also we'll be having 2 into 3 into 2 into 1. That is again 12 ways. So overall ways in which the assignment of task can be done in both case 1 and case 2 will be simply 12 plus 12, that is 24 ways. So in overall 24 ways, we can assign the task to these 5 people given the following criteria. Okay, so this question again I see is a bit tougher than the previous questions which we saw, and therefore, in such cases, sometimes we must not engage ourselves in such questions until and unless we have seen a similar question on a similar pattern. Okay, so this is the thing about permutation and combination. It is entirely different in approach, and you have to think about different possibilities which are there, right? So this is the catch. And I agree that a lot of us cannot think about all the possibilities. So you have to attempt such questions only when you have previously seen a similar kind of a question. And even if you are attempting a new question, you must assume that there is some risk which is being a part of this particular question, okay, of this topic of permutation and combination. So we'll move on to the next question now. We have question number 11. Here we'll be having all the manual cases being thought of again. So let us read it. The question says, there are 6 persons arranged in a row. So there are 6 persons. Let's call them 1, 2, 3, 4, 5 and 6, right? Another person has to shake hands with 3 of them. Okay, another person is there. So you might have seen those videos in which Mr. Bean is there and the Queen is coming, shaking hands with a row of people. So similar situation is there. Suppose there is, now the Queen is no more. We have, let's say, King Charles coming to shake hands with each of them, and the criteria being that he has to shake hands with 3 of them, so that he should not shake hands with 2 consecutive persons. So he has not to shake hands with any 2 consecutive persons. There must always a gap in between. Okay, so what are the different possible combinations or arrangements of handshakes which are possible? So that is something we have to think about. Okay, so in this question what we can do is that the king can either shake hands with the first guy, leave the second, and then shake hands with the third guy, then leave the fourth, and then shake hands with the fifth guy. So this is the first way of doing it. So he is leaving second, fourth, and sixth. Or what he can do is that he can shake hands with the first guy, leave the second guy, then with the third guy, then leave the fourth guy, fifth guy also, and then shake hands with the sixth guy. This is also one way possible. Then what another way is possible is that he's shaking hands with the first guy, leaving the second, also the third, and then shaking hands with the fourth guy, leaving the fifth guy, and then shaking hands with the sixth guy again. These are the three ways. And one more way is possible in which he ignores the first guy, shakes hand with the second guy, ignores the third, shakes hand with fourth, leave the fifth, and then again shakes hand with the sixth person. So these are the possible 4 ways in which he can do it. So here we have 1, 2, 3 and 4. Overall 4 ways in which this shaking of hands can be done. So the correct option is going to be option number B. So in this question there was no idea of multiplication or choice. This question can also be done manually, and if you look at the options, these options are quite small, so you can actually think of various cases which there are possible. Okay, so we'll move on to a more level up now, and these questions I simply suggest you do not mess with these questions. Do not get embroiled into such questions, because CSAT is a war. Okay, it is a battle in which you have to give your best in those 2 hours, especially when it is the hot season of May, and you're already exhausted by giving the GS1 paper. So in such battles you must not actually waste your energy over questions which will engage you in a perpetual conflict. So that is the idea we should follow while solving these questions here. So in this question, let us read it first. It says 4-digit number is to be formed using the digits 1, 2, 3 and 4 such that the 4 digits are not repeated, and also there are further terms and conditions. It says 2 and 3 should not immediately follow each other. Then 1 is not to be immediately followed by 3. So there should not be 1 and 3 anywhere in the sequence. Okay. Then further it says that 4 is not to appear at the last place. So 4 cannot occupy the last place. Simply 1 cannot occupy the first place. So these are various terms and conditions which are applied and that we have to think about. So such questions are, really bad questions. These questions are taking a lot of effort to solve, taking a lot of capacity of the brain to think about, but they might land you in such a position when your answer might be there, but it not might be the correct option. Okay, so these are the red flags that you have to avoid. I am repeating again for you. These are the red flags. Okay, so here we can solve this question by simply this method, that we can have 3 different cases: case 1, case 2 and case 3. In the case 1 we have last digit being occupied by in the case 1 we have last digit, since it cannot be occupied by 4, so we can have 3 cases. Last digit is either occupied by 1, or the last digit is occupied by 2, or the last digit is occupied by 3. Depending on these positions, we can further try to arrange the other letters here, and so we can have different arrangements possible. Let us say if we take the first case when 1 is at the end, we can have different arrangements, such as we can have either 3, 4, 2, 1, or we can have the arrangement, we can just interchange these values, 2, 4, 3, 1. Why these 2 only? Because here they are actually obeying the conditions. Here 2 and 3 are not immediately following each other, as you can see. There is a gap of 4. Then 1 should not be immediately followed by 3. There is no such case. So there is 3 followed by 1, but no 1 followed by 3. Okay. Then we have 4 not at the last place, and 1 is also not at the first place. So these 2 cases are possible only. In all other possible cases, one of the following criteria might not be being met. Okay. Similarly, if we look at this position here, we will have 3 cases. The 3 cases will be 3, 1, 4, 2. Apart from it, we can have 4, 3, 1, 2. And then finally, one more case which we can have is 3, 4, 1, 2. These are the 3 cases possible for case 2. And here you can see all the criteria is being satisfied. So what are the criteria? 2 and 3 are not following each other immediately. Then there is no sequence of 1 and then 3. And also 4 is not occupying the last place, 1 is not occupying the first place. Apart from it, no other way is possible. So here we have 1, 2 and 3. 3 more cases. And if you look at the last case, case number 3, there will be only one such case, which is nothing but 2, 1, 4 and 3. This is the only number which satisfies this criteria, where all these 4 criteria are met. Okay, so overall we are having 1, 2, 3, 4, 5 and 6. 6 such cases which satisfy all the terms and conditions. Okay, so there is nothing much you can do from your part. These are all hit and trial questions. What you have to do is you have to check for different options, different arrangements which are there. Suppose there are overall 5 letters to choose from, 4 letters to choose from. We have 1, 2, 3 and 4. Okay, and here we can have 4, then 3, then 2 and then 1. So overall we'll have 4 into 6, that is 24 ways. 24 such letters and 24 such arrangements will be there. Out of those arrangements, we have to just, actually eliminate the different options and nothing else. So these are the options which I showed to you. The approach is quite, random. There is no other way. You have to think about all the 24 ways in which they can be arranged and eliminate those which are not actually satisfying your criteria. That is the only way to solve such questions. Okay, moving on. We have this question number 13. It says the digits 1 to 9 are to be arranged in 3 rows in such a way that each row contains 3 digits and the number formed in the second row is twice the number formed in the first row, and the number formed in the third row is thrice the number formed in the first row. So what is the criteria is that we have 3 rows. So let us assume this is a matrix. Here we have the first row in which 3 numbers are placed. So in the second row there should be the numbers which are just twice of the first number, and then in the third row we should have numbers which are actually thrice the numbers in the first sequence. So it is actually such a question which will waste a lot of time which you might have. So what is the approach to solve this question? So we have here, since the repetition is not allowed and we have only these digits to be used in the first row, we have only the option of using 2, 3, 7 and 9 to be used in the first row. How many such combinations we can make? The question is saying that out of the numbers 2, 3, 7, 9, you can choose any 3 for the first row, and then you have to choose other numbers such that the second row is twice the first row, and the third row, the number whatever is formed is actually thrice the number formed in the first row. So again, what we have to do is hit and trial. We have to check for different combinations which are possible. Let's say we choose the number 2, 3 and 7. So the number is 237. We are filling the blocks in such a way that we have here 237. Now if we do that thing, what will happen is that we'll have to choose other numbers such that the numbers are double. So if we double up this number, if we multiply this particular number by 2, here we get 474, right? Here also the problem is the numbers are being repeated. So here you can see the number 7 is being repeated, and you do not want any repetition of digits. You want all the digits to be different. So that case 237 is not possible. So you have to choose with another set of digits. So what will that be? So we'll have to choose with another set of digits now. So as you can see, another set of digits can be 2, 3 and 9, right? So let us try this same thing with 2, 3 and 9. So we have 2, 3 and 9, and now we'll place these 2, 3 and 9 in that matrix. So let us have a look at that also. So let us place here 2, 3 and 9. When we multiply the digits by 2, we get 478. Now you can see something is good, no digit is being repeated. And then finally what we can do? We can multiply this number again by 3. So when we multiply this number by 3, what do we get? We get here 7. Then here we get how much? Here we get 1, and here we get 7. Again you can see that 7 is being repeated and we do not want any repetition. So this number is also not satisfying the criteria which we need, right? So we eliminate that also. After it, we have, let us say, another set of numbers. So these two sets are not possible. What about another set now? So we have, let's say, different combination of numbers. Let us choose 2, 7 and 3. So let us, now this, we are taking 2, 7 and 3 for example. So we'll fill the values with these numbers. So we're filling the first row with 2, 7 and 3. Now the second number is nothing but 2 times the first row, and the number here which will be found will be how much? 546. When you double it, the number becomes 546. Here also the good thing is no digit is being repeated. And finally, when you multiply this number by 3 to fill the third row, the number becomes 819. So the best thing here in this particular matrix is that none of the values are being repeated. So we have this one possible combination where the first row is filled with 2, 7 and 3. Similarly, we will have to check with different combinations that are possible, and since here are 4 numbers and we have to actually create 3 numbers, so here we have 4 choices, then we have 3, then we have 2. So overall we will be having 24 such numbers for which we'll have to check individually by multiplying each time. So you can understand how time consuming this question can be. This single question can waste around 30 minutes of your time, in which you can do at least 20 to 25 questions. These questions, as I have told you previously also, are big red flags that you have to avoid strategically, right? So apart from this, there will be one more combination that will be satisfying the idea, and the another combination will be simply 327. So if we take the combination of 327, we will be having here we'll have 3, here 2 and 7. When we multiply the number by 2, we get here 654. All the digits are different here again. And finally, when we multiply this number by 3, we get 981. Again also all the numbers are different. There is no repetition of digits going on. So here we have only 2 such possible arrangements, and therefore correct option is going to be option number C. But I have solved this question just to tell you that okay, it can be solved, but you must realize it is not worth solving. Okay, if you get that thing now, you will be quite happy in your life, because some things are there which should only be avoided in life. Okay, so that's a good life lesson, I guess. The wise men, what they do not have any magic formula to create happiness. They are just, they just ignore the problems that there are. They just avoid the grief which they can avoid. That is the wisest thing which you can do, and here it is completely applicable, as you can see. Now we have 14th question. This question again is a mind-boggling question, Do not want to mess with such questions in exam. So I just told you 3 red flags. Out of the total questions which we are going to discuss today, there are total 15 questions for permutation. 3 are red flags. Okay. Apart from it, there are simply 7 and 8 questions which you can easily do. And then there are 3 to 4 questions which need some level up. But those questions are even then solvable. These are those questions you have to leave at all costs. So the question says, 9 cups are to be placed in a table, arranged in equal number of rows and columns. So equal number of rows and columns means what? They have to be arranged in the form of a square, 3, 3 and 3. Out which 6 cups contain coffee and 3 cups contain tea. So we have to arrange them in rows of 3 into 3. 6 are containing coffee and 3 are containing tea. So in what ways they can be arranged so that each row should contain at least 1 cup of coffee? So each row should contain at least 1 cup of coffee. That simply means we have to have different arrangements. What are the different arrangements which are possible? So in order to arrange them, we can have 2 types of arrangements. We can have that in the first row, we are having 1 coffee and 2 tea. Then in the second row, we are having 2 coffee and 1 tea. And in the third row, we are having all the 3 as coffee. This is the first arrangement. Let us call it case 1. And the another arrangement which is possible is, which is case 2 simply. And that would be, first row is containing 2 coffee and 1 tea. Similarly, in second row, 2 coffee and 1 tea. And finally in the third row, 2 coffee and 1 tea. Okay, this is the possible arrangements which are there. Now let us try to expand all of them. So here we can have the row such that if 1 coffee and 2 teas are there, we can have 3 possible arrangements. We can have coffee, tea and tea. Further we can have tea, coffee and tea, and then we can have tea, tea and coffee. These are the 3 possible arrangements. Similarly here also we will have coffee, coffee, tea, coffee, tea, coffee, and then we can have tea, coffee and coffee. These are again the 3 possible arrangements. Here since all of them are coffee, we have only one arrangement which is C, C and C. Okay, so there are, in one single matrix, in this row we can have 3 options available or 3 arrangements possible. In this row again we have 3 arrangements possible, and in this row we have only one arrangement. So these are the overall 9 ways in which each row can be arranged. And now these rows can be further arranged by themselves. So instead of having this as the first row, this as the second row, you can place it as the first row. This becomes the second row, this becomes the third row. So these rows can be interchanged in between also. So if we are calling this, let's say, if we are calling this as row 1, you're calling this as row 2, and you are calling this as row 3, we are having 3 rows. What are the possible arrangements? You can have either 1, 2 and 3, or you can have 1, 3, 2, or you can put 2 at the first place, you have 2, 1, 3, or you can have 2, 3, 1. Apart from it, you can also place third at the first position, and you can have 3, 1, 2, and you can have 3, 2, 1. These are the overall 6 ways in which these rows can further be arranged. So this arrangement, this 3 into 3 into 1, this arrangement is there. Apart from it, the rows can be arranged in 1, 2, 3, 4, 5 and 6 number of ways. So for the first case we have 3 into 3 into 6, which is overall 54 ways of arranging. I know it might just go over the head. I have total agreements with you, but this is the way the things are going in PNC. Some questions are to be left. If you try to think such things in the exam hall, you'll be boggled completely. Okay, so you can just think about it when you are free at your room. That is fine. You can give almost half an hour for this particular question and think about the various arrangements which I have drawn. But at the exam hall, just avoid them. When we talk about this particular arrangement, we can have here, in the first row we can have 3 arrangements again. We can have C, C and T. We can have C, T and C, and we can have T, C, C. So each row there we can have 3 arrangements. So let me use a different pen. So in the first row we can have 3 arrangements. Here also we can have 3 arrangements, and here also we can have 3 arrangements, right? Since all the rows are identicals, we need not to actually arrange the rows among themselves. All the rows are same: 2 coffee, 1 tea, 2 coffee, 1 tea, and 2 coffee, 1 tea. Here the rows were different: 1 coffee, 2 tea, 2 coffee, 1 tea, and 3 coffee. So this was a different case. So this, if we are talking about this case, we will have 3 into 3 into 3, that is 27 ways. So overall, if we talk about it, from the case 1 we have 54 ways, from case 2 we have 27 ways. Overall number of ways are going to be how much? Overall ways are going to be 54 plus 27, the sum is 81. So the answer becomes 81. So we can have different arrangements. So let me just show you one of the arrangement. One of the arrangement can be, in the first row you can have coffee, then tea, and then tea. In the second row you can have tea, coffee, coffee. In the third row you are having all coffee. So this is one arrangement of the first case. And you can have 54 such arrangements possible. Total 54 arrangements in this way. Similarly, if we talk about case 2, we can have first row be having C, C, T. Here we can have C, T, C. Here we can have T, C, C. And similarly, 27 more arrangements are possible. So overall we have 54 plus 27, 2 cases, that is 87 arrangements. So you need not to bother much about this question. These 3 questions were big red flags that you have to just avoid. Right? Moving on to the last question of the day. And this question is such a lovely question. Such questions actually, make, excited that how much UPSC thinks about CSAT, how much care and thought is given after each question which is being asked in CSAT. And this is the best question you can find, which actually can steal your heart. This question says, how many 5-digit prime numbers can be obtained by using all the digits 1, 2, 3, 4 and 5 without repetition of digits? So if we just ignore the prime number part, it is simply a permutation and combination problem, right? That we have 5 letters, we have to find different 5-letter words from it without repetition of digits. That is the basic idea of permutation and combination. But here just one word is there which is changing all the story. So I want you to pause this video right now, just give it a thought. Please try to think about this question, and when you will be unpausing the video, you'll be surprised to know that it is actually something quite different. So okay, so I guess now you might have paused, thought about it, and then again played the video, and now I'm telling the catch. So here the spoiler is, when you add up all these numbers, you have 1, 2, 3, 4 and 5. When you add up all these numbers, the sum becomes what? It becomes 3 and 3, 6, 4, 10 and then 15. The sum becomes 15, which means whatever digit you create using these numbers, the sum of digit will always be 15. And since 15 is divisible by 3 perfectly, the number you create will definitely be divisible by 3. And since it is divisible by 3, it cannot be a prime number. So you can have only 0 such prime numbers by arranging all these 1, 2, 3, 4 and 5. So as you can see, it is quite interesting that the question appears to be a question of permutation and combination, but in reality is just a simple, very simple and trivial question of number system. Okay guys, so that was all about today. And I think we should end our discussion by thanking you for your patience and support and your persistence with CSAT. So we have actually covered a very long journey, which is going to end very soon now. And I hope that the whole discussion of permutation would be very useful for your CSAT. And you'll be crossing that 33% barrier very fine.